Hi, it's Jan Beta, and today we're going to talk about the Commodore VIC-20 again. In particular, this Diagnostics cartridge, which I tried to use in the previous video and it didn't quite work as expected. So we're diagnosing the Diagnostics today. This is the board I repaired in the previous video and it still works fine as far as I can see. I tried to use the Diagnostics. This is a replica of the original Commodore issued VIC-20 Diagnostics that they used in their factories to troubleshoot these and check them before they left the factory. This is an open source project from Sven Petersen, who reverse engineered the original Diagnostics card, which is based on the Super Expander card, one of the first memory expansions and also basic expansions that was available back in the day for the Commodore VIC-20. And he found out that the Diagnostics card was based on the same PCB. The Diagnostics uses a tiny bit of RAM, not quite the 3 kilobytes of RAM that the Super Expander had on board, but I think 1 kilobyte is on this originally. This particular one got sent to me by John, who also donated the VIC-20 board, and he soldered Sven's project up, but it didn't quite work. It also comes with the full diagnostic harness, so we can connect to all the ports on the VIC-20, and the Diagnostics is checking the ports basically, and the keyboard connector goes on here. So this is a full diagnostic. It's checking the RAM, it's checking the ports for faults, and it is a super useful tool for troubleshooting these VIC-20s, but this one didn't quite work, so we're going to figure out why that is. I'm going to show you what it does at first. So here's what the not quite working Diagnostics do with a working VIC-20 actually. It is supposed to go through the RAM, which it does. It is supposed to show a real-time clock there, which it doesn't quite do. It's flickering a bit, but it doesn't show any particular clock-looking thing. It shows the days, but it's also flickering. The screen flickering is actually normal. It checks the screen RAM, and then it fails on the first ROM check. No matter what VIC-20 I hook up to this, it always does this with different error codes each time. There's definitely something wrong with the cartridge. I used another version of the same Diagnostics and that passed on this VIC-20 and on my other VIC-20s that are in good order. So let's open up the cartridge and have a look. And maybe we have to check the test harness as well. On the previous video, which I'm going to link in the video description as well, so you can see me using this and being confused about it. There were comments by both Sven Petersen, who made this available, and by Dave Curran, who also made a Diagnostics harness that I used and that worked. And both pointed out things that I want to talk about that might be wrong with this. So without further ado, let's open up the cartridge. And of course, this is an open source project, so if you want to make your own, you can just download the Gerber files for all these little circuit boards for the harness and for the cartridge. You need a couple of components, obviously, to make this work. It's all laid out pretty nicely in Sven's GitHub, and there's some additional information and a full manual for that in a PDF that's also linked in the GitHub. I'm going to link that in the video description. If you want to make your own, you can just upload the Gerbers to your favorite PCB manufacturer, and it's pretty easy to solder one of these up yourself in case you want to fix VIC-20s or VC-20s. This is probably a good segue to thanking the sponsor for this video, which is of course PCBWay, my favorite manufacturer of prototype PCBs of all kinds. And they can also do these PCBs, of course, because they are standard PCBs. So you just upload the Gerbers and get your PCB by mail. Their service is excellent. They also offer CNC machining, 3D printing, sheet metal fabrication, injection molding, you name it. Everything the tinkerer needs. The quality of all these services is excellent and delivery is fast. Pricing is super reasonable. So I highly recommend checking out the link in the video description. Let's get back to our diagnostics. So at this point, I don't think there's anything wrong with the test harness. That looks good. I haven't opened these up. These are 3D printed cases for all the individual parts, and the wire interconnects look fine. I guess the PCBs are also fine. There's not much on there. They're basically just connecting between these connectors. And the magic happens in this. That's where the diagnostic software is on an EPROM, and the extra RAM is to make this work. So let's open this up. Should be one screw in the back. This is a pretty nice 3D printed enclosure that John made. Just putting on my ESD wrist strap here to not risk damaging this. There we are. This is our VIC-20 Diag. And as I said, this is a clone of the VIC-20 Super Expander cartridge. Sven dubbed it the Super Expander 2. Basically, the only change to this is that this can take 28-pin EPROMs, like more modern EPROMs, up to 27512, starting with a 2764. I think the original cartridge had a 2732, which has 24 pins. And yeah, he changed the layout for that. This can take 2 ROMs. The Super Expander probably had 2 2732 compatible mask ROMs in there. And there's also jumpers to set it up for different EPROM types and different start addresses. And these sockets here are for the RAM. There's also a reset switch added here that's not populated on this board. I might just go in and populate that. First thing that I noticed is that there isn't any RAM in here. So clearly that's why this didn't do what it's supposed to do, I would guess. These are all populated with 2 114 static RAM chips on the original Super Expander cartridge. And you can use this as a Super Expander if you put the correct ROM on there. There's also a GitHub page for that from Sven Petersen. For the Diagnostics cartridge, we only need these two to be populated with 2 114 static RAM that I think I have somewhere in my parts bin. So we're just going to see what happens if I just populate these. Otherwise, pretty straightforward. Little decoupling capacitors to clean up the voltages going into the chips and the noise generated by the chips. A larger 100 microfarad filter capacitor, some resistors of course, but the rest is all just sockets and jumpers. And you can set this up according to the PDF that Sven offers on the GitHub for different configurations, of course, because this can be used as a Super Expander, it can just be used as a cartridge, which I believe is what it does in this configuration. You just have a ROM in there and that's just starting the ROM, which it clearly does. It does start up. It just doesn't pass the tests. Long story short, let's put some RAM in here and see what it does. So in my C64 parts bin, I found these Tesla brand 2114 chips, which should be absolutely fine. These are new old stock. Just going to use my pin straightener here and put them in. RAM 1, RAM 2. Hope these are good. Can't test these, of course. But I just assume that they are working fine, or at least better than no RAM. So this should now be fully functional, in theory, if that is the only fault. It might be that the ROM is the wrong ROM, but I think John probably just used the ROM from Sven's GitHub, and that should be the VIC-20 Diagnostics, the PAL version and the NTSC version, which are slightly different. We're going to look into that in a second. And yeah, the Tesla RAMs, classic. Nothing to do with the new Tesla company. I wouldn't touch that with a stick. So here we go. Trying to put this in there just without the casing to test this. Let's see if it actually works now. Fingers crossed. Chances are this is just going to work and pass the test now. With the harness connected, of course. Without the harness, it's not going to do much. With the harness and the RAM, it should now just pass the test, I think. And you can see that this is the NTSC VIC-20 Diagnostics because it says VIC-20. The PAL version of the Diagnostics actually says VIC-20 as it was called in Germany. This takes a long time to test. possibly this still doesn't work correctly. Ah, that's a noob fault. I put the RAM chips in the wrong way, so probably they are toast now. They just got voltage on the wrong pin. I feel like a bit of a fool. And I hope I didn't burn these RAM chips. Things like that happen if you don't pay attention and just want to make a quick video. So these clearly have to be oriented like this, with pin 1 facing towards the cartridge port here. It's even the sockets are in the correct orientation. You can see a little cutout here, and that's also represented on the silk screen. So this is the correct orientation. I hope these still work. Usually they can take a bit of voltage up the wrong pin for a while, but yeah, they might as well be toast. We're going to see. Let's see. Maybe it still works. Nope, it doesn't work at all now. So I possibly... No, there we are. Cartridge port is a bit dirty. Now the clock is showing there. That's good. It's actually counting up. That's what it's supposed to do. Let's see if it now continues with all the tests. It takes a while, quite a long while actually, but that's supposedly normal. Now it's testing the screen RAM. Keyboard test is bad for some reason. Okay, but it tested the ROMs correctly. That is interesting. Why did the keyboard test is bad now? We have the keyboard plug connected here. Let's see if we can change this to the PAL version of the Diagnostics, which should also be on this EPROM in theory. And then maybe we can make this switchable. I'm just going to have a sneak peek at what kind of EPROM is in here, because the jumper settings are needed to set it up for the correct EPROM, and I don't know which one is in here. Oh, it's the M2764A, so it is an 8K EPROM actually. And I think the Diagnostics are 8K. So we would need to put another EPROM type in there that we're going to have to burn. We can totally do that. So just scrolling through Sven Petersen's GitHub here for the VIC-20 Diagnostics, and there is a directory for the firmware with different versions, and indeed the original firmware is just 4K. He provides 2 different versions of these 4K files here. Don't know which one is the correct one, but there's also a version for a 27C512, which is a 64 kilobyte EPROM, and I think I have plenty of those. We're just going to use that version that should have the PAL and the NTSC version on it. That's what I was after. So we're going to download that, put it in an EPROM, and set up the card for a 27C512 EPROM and make that switchable between PAL and NTSC. I think that's the way to go. So we're doing away with the old UV erasable EPROM. I think I have 27C512 that are electrically erasable. That should make things a bit easier. These need UV light to be erased, but they can be rewritten after that. And the electrically erasable EPROMs, as the name suggests, you can just electrically erase with your EPROM programmer. So I found one of these Winbond W27C512, which work fine for most retro computer stuff that I've thrown them at. Got my EPROM programmer out, which is an old TL866. We're going to have to download the file, the aforementioned file, from Sven's GitHub again. Binary. Starting up my programmer software. It's W20C512. It's a Winbond DIP28. Select. And this should be a 64K standard binary. There we are. Yeah, cycle, color, test, RAM check. This should have, yeah, in the first block there's 2 4K blocks of the diagnostics. One is PAL, one is NTSC, and should be able to program this on our EPROM now. Let's do that. Takes a while, but these are pretty fast actually. And then we're going to have to set up our diagnostics card according to this new EPROM type that we're using. And I'm going to make sure to put it in the right way round this time. It's in there, nice and tight. Let's see about these jumpers. The instructions for the EPROM jumpers are under the EPROM, quite conveniently. Just so you can see this. So for 27512, which this is, we can wire this up to block 5, which is where our diagnostics are supposed to start. This jumper here, the right 3 pins, just no setting, and CS1 for the first slot here set to block 5, which is where the diagnostics are supposed to start at memory address A000. We can hardwire these address lines, A14 and A15. These can just be hardwired in theory, and with the EPROM in place in the correct orientation, it should in theory start up the diagnostics like this. Ooh, that doesn't look too good. Okay, I figured it out. There's actually 2 extra jumpers here for the second IC and here for the first IC, which we are using. And we have to set the block size that the EPROM gives to the CPU up to 4 kilobytes, because that's what the diagnostics is. So there's a setting for 4 and for 8 kilobytes. And we have to put this jumper here on the left pins. And now the rest of the jumper settings is correct. So A14 and A15 are closed. A13 is open at this point, and this little jumper is 4K. The setting for the first IC is block 5. So this should now all be correct. Maybe it's finally going to start up even. Yay! And this is clearly the NTSC version again. Let's see if it passes the keyboard test. I'm actually using the other VIC-20 board that was mostly okay. It does test the keyboard as bad still. So maybe we have a problem with our keyboard adapter there. Going to have to double check that. But this is how to set up the cartridge, I think. I'm going to try to switch it to the PAL diagnostics now, which should technically just be a matter of closing A13, the jumper here. And now we should be starting the other portion of code in the EPROM. Let's see if we get the VIC-20. Yep, the border is cut off because this is the PAL version running on an NTSC VIC-20. But yeah, we can switch this between the 2 versions in existence of this diagnostic ROM. This is the NTSC version again. Yeah, it does show me the keyboard as bad in both versions though. Kind of want to test the other harness to see if that gives me a better result here, which is not as sophisticated as the one that Sven provides on the GitHub, but maybe this passes the test. Then we would have some kind of hint towards what's wrong with this one, I guess. Let's see if this works better in any way. Yeah. That works better now. So we're going to have to double check our harness as well. Let's take that apart and have a look, I guess. Maybe this connection here is not good. Yeah, there's not much that can go wrong with this. Maybe the resistor is the wrong value or something. I'm going to have to double check with the GitHub. Not sure what these jumpers are for and this joystick connection. The restore on the keyboard PCB, which is this here. It's clearly connected. Going to see if there's a connection between these 2 things if I plug this into here. Yeah. Just going to resolder these joints, I think. So this seems to be hunky-dory. This is clearly connected the correct way. So I read up on this, and these should be 27 ohms resistors, I think. Yep, 26.6, 26.7, that's all right. These little jumpers, solder jumpers, are just closed by default. They are 0 ohms bridges on the original one. And this little joystick 3 connector isn't used by the diagnostics. It's just there to connect something for experimental purposes or in case you want to make your own diagnostic software that checks more things. The loopback stuff for the keyboard, which was failing, is all on this little PCB. So we're going to take a closer look at this and check that. It might be that we have a broken connection between these loopbacks here. Just going to resolder all these connections. There's nothing much that can go wrong with this really, so I wonder why it doesn't completely work. Does look good actually. Anyway, yeah, reflowing everything. Maybe reflowing helped in some way. Also going to spray contact cleaner into all the contacts. The removable contacts. Let's see. No, still tests as bad. How very peculiar. There's not much it is testing there really. Let's remove the keyboard PCB. Still tests as bad. Removing the joystick port thing. Oh, now it says the joystick port is bad. So maybe we have a problem with our joystick port test thingy. That seems to be an explanation. Let's just put the other joystick port dongle in there. It's just a loopback basically. See if it passes all the tests now. Yep. So something's wrong with our joystick port test cable there, I think. Going to have to check that. I'm not going to stop before this diagnostics passes. The VIC-20 is alright actually. Maybe this has the connections upside down, something like that. This is how I usually test these D9 or other D-sub connectors. Just plug in another gender of plug in there and we can easily measure the pins. And on this end, I'm just using a component lag. So this should be connected to pin 1, which it is. Oh, that's the one that's not connected. So this should probably be pin 2. Yep. No shorts in the cable. All pins are connected. Now we only have to figure out if this is actually the correct orientation. I think this might just be connected backwards. The wire is wound through here for strain relief, and these work in a way that you press them together, and they're little knives, basically, little blades that cut into these insulated wires and make the connections in the correct spots. But it's not very clear from the instructions which way the cable is coming out. It's pictured with the cable coming out this way, I think. Okay, according to the silk screen, which we can't see anymore, pin 1 should be this one, bottom row of the right row of connectors there. So we can, in theory, just see if that is our pin 1 that goes through to pin 1 on our connector, on our DE9 connector. This should go to here, which it doesn't. Okay, this is pin 1. That is the wrong way around. We're going to have to take this apart because there's one wire that's not connected clearly on this end. So if we connect that to the wrong pin on this end, it's not going to work. So let's see if we can get this apart. I think it should just be a matter of brute forcing this with a screwdriver maybe. Yep. And the strain relief doesn't work anymore because we broke that off. Ah, that sucks so much. I'm going to have to remake this cable from scratch, I think, but I don't have the parts for that. But for now, we can just use this, and then the test passes. And clearly it has nothing to do with the keyboard connector itself, or with the little keyboard daughter PCB there, which is kind of interesting. It fails on the keyboard test because the joystick connector thingy is bad. And it passes with this little adapter thing. Jan from the future here. I read through the PDF regarding the joystick port test cable again, and it indeed is the exact same cable used for the Commodore 64 diagnostics, which I of course have, also designed by or replicated by Sven Petersen. And I just took one of the cables from that and connected it the correct way around, and now it passes the test. So it was definitely the joystick cable, the joystick test cable. I'm going to have to remake that for sure. That's the only thing that was wrong with it in the end. One bad cable, probably wired the wrong way around, but I couldn't keep the connector together. These are made for pushing them together one time and never to be separated again, basically. So yeah, I'm going to source the appropriate connectors, and until then I'm just going to use the cable from my Commodore 64 test harness, I guess. What else? We can put a reset switch in our cartridge. I think I want to do that. That shouldn't be much effort. So this has the footprint for one of these little tactile buttons, and I have some in my parts bin, so I'm just going to put one in there for a reset, which is kind of useful, I guess. Not crucial, but doesn't hurt to have that on there. And I also want to make this switchable from the outset, so we're going to make a little like physical switch for changing between the NTSC and the PAL version of the Diagnostics, which will be handy. And I'm just going to cut that out, I think. Yeah, it doesn't look great, but hey, this is a cartridge that shall be used and not look pretty. Switch! So I have some of these from my parts bin. These should fit the casing fine, and they're literally just two contacts on-off. So single pole, single throw. But that's all we need. We just need to replicate the functionality of this jumper here. Just closing and opening that. So we can just drill a hole right on the edge here, I think, and this should fit in there fine. Drilling a hole where the rain gets in. Yeah, that's not bad. Not going to be able to fit a crimped connector in there, but we can totally just use wires and solder them to the back of the circuit board, so we can still use the jumper. So these two are connected, poking out here, and we're going to solder them to the switch. Sorry for the low production values in this video, but this is just very spontaneous, basically, because I wanted to make this work in some way and make it work better. Why not? Yeah, that's looking good. So, this now has a switch. We're going to put a little label on there, and it should, in theory, switch between the NTSC and the PAL version of the Diagnostics. And of course we should also be able to reset the card with our new reset switch. That's our VIC-20 Diagnostics. That's our VIC-20 Diagnostics. Let's reset it. Yay! Even that works. Yay! Reset. Nice! So there we go. PAL NTSC. PAL, yeah. It doesn't look great, but I can see what it means. And I can always use this video as a reference. And if you are doing something similar, you can always do it a lot nicer, I assume, than what I just showed you. This is more of a proof of a concept. So still a few loose ends because I don't have the parts, but I made this diagnostic a lot more useful for my purposes, and I hope this explains some things that you can do with the Super Expander cartridges. I'm going to link the GitHub repositories in the video description so you can make your own Super Expander in case you want to. As I said, it also has some basic functionality that's added, some more basic commands and things like that. Pretty useful little cartridge and very widely available back in the day, and many people bought them. I think that's it for today. Thank you very much for your time. Thanks for watching. Special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are on my website and in the video description in case you want to give me some support and make more of these videos possible. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye. Let's run PAL again.